Today's lesson, 1-7 from our textbook, explicit formulas for sequences. Let's start with the word explicit to begin with, even though we have our learning goals up here. We're going to be able to evaluate sequences. We're going to be able to use functions to solve real-world problems. But explicit, think back. Where does that word come from? Where have you seen it before, heard it before? I would start with English class. If your teacher said, or you were reading a passage that says, Susie made her marks explicitly, that tells you something about what she said. So you've heard that word before, but now we want to double check because there's more than just that one word that's new for this section. So check your notes in your reading. What did you do? What did you see? Because we need to be able to match each word with its definition. So let's look around and see the different words, and then we'll go through the definitions. And then when you come back to class, you want to be able to match them up, be able to come up here and assign them to each call out. So explicitly is one of the words. Nth term. So term by itself has a definition. Subscript, index, and sequence. Those are the words that we want to make sure we have good definitions for, and those definitions come from the gray list. One of the definitions is any general term. Another definition, each item in a list. Third definition, an ordered list. The word directly is one of the definitions. The number or variable written below and right is a definition. And the last one to choose from, it indicates position. So you should be able to grab any one of these definitions and move them to the appropriate call-out. So look at your definitions. If you have any questions on any of them, please ask when you come to class. We're going to go through and sort of do some of them also as we go, so that might help you. But tomorrow we will see them in our work. All right. The numbers, the color's probably a little bad here, but let's go with it. We can change it later. I want you to, as we say, consider this sequence. So look up in this sequence of the numbers 15, 17, 19, 21, 23, and so on. You should start, anytime you see a sequence, look for a pattern. And there is a definite pattern here. And that pattern should be able to, or allow us to, answer the following questions. What is the value of the fourth term? So if you look through this list, you're saying, well, let's see. That's the first term. Then I have a second term. Then I have a third term, fourth term, fifth term. So it says, what is the value of the fourth term? I believe we would have to say 21. It says, find t sub 8. Well, in looking at that pattern that you started with, you hopefully saw something happening between every set of numbers. And if you did, then you should be able to lengthen this list and get it to where you need. And right now, as you can see, we only have 5 terms, so we would need a 6th, a 7th, and an 8th. And not too hard, hopefully, to see that the constant difference is 2. So I believe 2 added to 23 would give us 25. 2 added to 25 gives us 27. And 2 added to 27 gives us 29. So we would say, find t sub 8. T sub 8 is 29. Now notice that this is a variable with a subscript. It stands for position. Your subscript is always an indicator of where in the list you are at. So look carefully and add and count carefully. That will be key. So in doing so, we just arrived at identifying the pattern, counting the terms as you figure them out, counting how many you already have, adding that same pattern over and over and over. And on these explicit sequences, you are keeping that pattern constant, and it doesn't have to be add. So just keep your mind open. It's not going to always be an add to, add to, add to, a real simple combination. All right, let's change it up a little. Now what if I say consider this sequence? And if you look at this one, you say, oh wow, I don't have a T with a subscript of what I'm looking for this time. T sub n. N could be any term in your list. So any term in your list, any term in your sequence, it could be the first term, could be the second, could be the 88th. So n can be a variable. With that, if the question said, what is the value of the third term? Most people would say, well, let's see. If I wanted the first term, I'd put a 1 in for n. Do the math, order of operations, and you can see 20 results. If I wanted a second term, do the same thing. If I wanted the third term, do the same thing. So what is the value of the third term? It could allow us to put the 3 in, do the arithmetic, and we would be at the third term. We really would not have to have done these first 2 at all. If it said list the first 3 terms, then we would have. But if this wanted the third term, and that's what our question says, what is the value of the third term, we could have done just the 1 and come up with 24. Once you find the pattern, generate the next terms in the sequence. So if it asks for the first 4, first 5, first 6, you could do so quite quickly. And you are noticing as you go through here, there's a pattern. So when we see this is another just simple add 2, add 2, add 2, a little different than the last one looked though, because we started with a generic equation, formula. Now, this is an example of how we take this to our real world examples. Suppose you drop a ball from the top of a 50-foot wall, and on each bounce the ball rises to 75% of its previous height. The heights of the ball after each bounce form a sequence. Write the first 3 terms of the sequence, and then after how many bounces will the ball rise less than 10 feet. Now on this one I'm going to set up the scenario and actually give you a visual, and then I would like you to finish the math involved and bring that with you, and we'll have it as a point of discussion. So let's start easy enough. We have a wall. We're going to drop the ball from the top of that wall. So let's assume right now that that's our wall. Okay? And we know the top of that wall is 50 feet. So this ball is sitting up here, and it's going to be dropped. We know that's 50 feet. And on each bounce, the ball rises. So assume this is the ground. Each bounce, the ball rises 75% of its previous height. So here's the first bounce. And it rises to 75%, we'll say, which is about right there. And then down. And then it'll rise 75% again. And then down. And it will continue this pattern. So we've got that 75% going on. Now, again, we started at 50. So your key piece, in order to get this sequence, they ask the heights of the ball after each bounce form a sequence. So the question out there is 50 part of the sequence? Are these part of the sequence, etc., etc.? Or, because it says, I think this is the key piece, the height of the ball after each bounce. So right now the question is, did it bounce? The answer is no, correct. In your thinking, so this would have to be your first term, this would have to be your second term, this would be your third, etc., etc. So calculate what 75% of that initial height is. It would be your first term, then the second, then the third. You have your first part done. And then you have to look at your numbers and see where you're at, because it's asking after how many bounces will the ball rise less than 10 feet. So they want to know, when will it get to this point? So those are two things you can do. Write out, put them in your paper, your notes, and we will discuss that when we come to class. So there's a good example of a real world situation. All right, bring all those and any other questions you have with you to class tomorrow.